Today we're going to be solving radical equations, and a radical is this symbol. So in order to solve a radical equation, we're going to isolate the radical. So what I'm going to do on this first example, I'm going to subtract 3 on both sides. I am left with negative 4th root of m equals 0 minus 3 is negative 3. Next, I'm going to divide by a -1 to get rid of the negatives. I am left with the 4th root of m equals a positive 3. So that is step 1 completed. We isolated the radical. The radical is now by itself. The next step is to raise each side of the equation to the power of the index. The index is this number up here. This number. So in this problem, what is my index? 4. So I'm going to raise each side of the equation to 4. What this does is it cancels out the root or the radical, and that cancels out. So I am left with m equals, what is 3 to the 4th power? 81. And that was me solving the equation. Now, the most important step is to check for extraneous solutions. So I'm going to write the problem, the original problem again. And instead of writing the letter M, I'm going to put 81 right there. And let's evaluate. 3 minus, what is the 4th root of 81? 3. 3 minus 3 is 0. Both sides match. 0 equals 0 is a true statement. That means this is my answer, 81. Here's my radical. I'm going to isolate it. So I'm going to subtract 10 from both sides. I am left with the square root of 6w minus 5 equals 3 minus 10 is -7. So let's pause here and write some notes. Whenever you have a radical equaling a negative number, just like I have here, I have a radical equaling a negative number. Whenever you have this, the answer is no solution. And this only applies when your index is even. So guys, nothing is written right here. What is my index? 2. For a square root, your index is 2. That's an even number. Whenever this is an even number and it equals a negative, it's no solution. So you can stop here. You can stop here and just write no solution. I'm going to keep going just so you can see. I'm going to go ahead and square both sides. I'm left with 6w minus 5 equals, what's -7 squared? 49. Okay, now I'm going to solve. So I'm going to add 5. I get 6w is equal to 54. Now I'm going to divide both sides by 6. I get w equals 9. Now I'm going to check for extraneous solutions. In order to check, I'm going to write the entire thing again. And you're going to see why my answer was no solution. Inside for the w, I'm going to put in 9. All right, what's 6 times 9? So I get 54 minus 5, the square root of that, and I add 10. 54 minus 5 is 49. And I'm supposed to get 3. What's the square root of 49? 7 plus 10 is supposed to equal 3. 7 plus 10 is 17. Is this a true statement? No, this is not true. That's why our answer is no solution. Okay, so guys, you don't have to do all the things that I did. Once you see that you get a radical with an even index equaling a negative number, you can stop there and say no solution. Okay, next example. I notice I have a 1/3 right here. How can you rewrite this with a radical? Yep, it's a cubed root. This is the exact same thing. Exact same thing. I'm going to subtract 11. And I get the cubed root of 7p minus 1 equals 7 minus 11 is -4. Is this allowed, guys? Let's look back at the notes. What did I say? When it's even, it's no solution. Is 3 even? That's odd. So we can do this. Okay? The reason why is because you do cubed roots of negatives all the time. What's the answer to this one? -2. You guys can do negative numbers with the cubed root. Okay? You just can't do it with the even. All right, so let's continue solving. I'm going to raise to the power of 3 so that those cancel. Raise to the power of 3. So I get 7p minus 1 equals, what's -4 times -4 times -4? Do it 3 times. -64. Good. And I'm going to add 1. I get 7p equals -63. Divide both sides by 7. You get p is equal to -9. Let's check our answer. So I got 7p minus 1, and I'm going to do the cubed root of that, plus 11 equals 7. That's my original problem. Remember, a 1/3 is the same thing as a cubed root. And instead of a p, I'm going to write -9. Okay, so I'm going to get cubed root 7 times -9 is -63. -3 minus 1 is -64. And what's the cubed root of -64? -4, because -4 multiplied by itself 3 times will give you -64. -4 plus 11 is 7. So I get 7 equals 7. That's true. That means this is your answer. We checked it. I'm going to divide both sides by 4. I get the square root of 3x plus 15 equals 3 square root of x. And I can't really isolate anymore. So I'm going to go ahead and square both sides. Square this side and square this entire side. Those cancel. I'm left with 3x plus 15 equals 9x. Because this square root cancels with that, and you also have to square the 3. Now we just solve. Subtract 3x. I get 15 equals 6x. Divide by 6. All right, so that's my answer. Let me just simplify it. I'll divide the top by 3 and the denominator by 3. So I get x is equal to 5/2. Now I'm going to check this one with you. This one's a little bit more complicated because we have some fractions. But just follow along. Okay, everywhere that I have an x, I'm going to plug in 5/2. Oh, and I forgot this symbol. Okay, so let's evaluate. 3 times 5, this is 15 over 2. Everything else, I'll just bring it down. Okay, and if I want to add fractions, you need the same denominator. So I'm going to divide top and bottom by 2. So what I get is 4 on the outside. That didn't change. 15 times 2 is 30. Next, I can combine the fractions since I have the same denominator. This is 15. Oh, 15 plus 30 is 45. So this is 45 over 2. Now, we're going to simplify this. We're going to break apart this radical. What two numbers can give you 45? Yep, 9 and 5. So I can write this radical as 4 times square root of 9 times square root of 5 over square root of 2. I just broke it apart. Do you guys know what the square root of 9 is? This is just 3. All right. So I get 4 times 3 is 12, and you have square root of 5 over square root of 2. You can combine this radical into 5 over 2. And that's what matches this side. So this is a solution. We plugged it in, and we got a true statement. All right, so I'm just going to go ahead and I'm going to square both sides because the radical is already by itself over here. You need to square the entire thing. The square root cancels out with the squared. What I have is 51 minus 5y equals, this is a squared. That means you write it 2 times. I saw my last class do this. Y squared minus 121. That's incorrect. You don't do that. You have to write it twice. You cannot do that. Okay, let's go ahead and multiply it out. Y times y is y squared. Y times negative 11, negative 11y. Now let's do the next number. Negative 11 times this y is negative 11y. Negative 11 times negative 11 is positive 121. This side can just come down. You can combine the middle. Negative 11 and negative 11 is negative 22. Bring down the rest. All right, now bring the 5y over. It becomes plus. Bring the 51 over. It becomes a minus. So this is y squared. Negative 22 plus 5, that's negative 17. 121 minus 51 is 70. There we go. There's nothing left over here, so that's just 0. All right, I'm going to do an eye chart. 2 numbers that multiply to 70 but add to negative 17. Yep, negative 10, negative 7. So I get y minus 10 and y minus 7 are my factors. These are called factors. When they're in parentheses, these are your factors. That means your solutions, or your possible solutions, we always have to check, will be 10 and 7. All right, now let's make sure we check. So the original problem is this. I'm going to plug in 10s first. So I'll plug in a 10 right here and right here, because those are the 2 places where I had y's. All right, so let's simplify this. 51 minus 5 times 10 is 50. 10 minus 11 is negative 1. 51 minus 50 is 1. The square root of 1 is 1. This is not true. So that is not an answer. Let's test the 7. The original problem is 51 minus 5 equals that. I'm going to plug in some 7s now. Okay. This is 51 minus 35 equals 7 minus 11 is negative 4. 51 minus 35 is 16. The square root of 16 is 4. This is not true. So that is not a solution either. So guys, we didn't get any solutions. Your answer is no solution. None of them worked when I plugged it in to check.